You guys are able to see the screen?
Yes, sir.
Yeah. Okay, today is going to be a very today's content is going to be very practically relevant and one which you will definitely utilize for all your designs if you're really thinking that climate plays a vital role in your building design. So, what is the content we are going to look in for today? We are starting from the cycle 3. So, the movement of sun. How are we going to map the movement of sun? So, what we need a sun path diagram. How are we going to read a sun path diagram? And how to calculate what is the like for human beings to be tracked up on the planet Earth. What is the method we use? Could be human beings, or could be for places. Can someone unmute your mic and speak on this? How do we geographically locate a place, guys?
So can you repeat what you asked?
Longitudes and latitudes.
Yeah, no, Satyajit, what I was asking is how do we geographically locate a place or a person in the Earth, on the Earth? Someone said longitude and latitude. Yes. So these become like the GPS coordinates, isn't so? Isn't it, guys? So
Yes.
with that, you'll be able to track
Yes.
someone. Yeah. So similarly, what are we going to do for a sun? How are we going to identify which part or which position the sun moves and where in which angle it's going to cast its sun as it casts its shadow rays, and where do we need to have a provide a shading device? So this is all what we're going to look in for today's class. So like latitude and longitude, what we use for us to globally identify ourselves, to identify sun on the sky, on what location we use two coordinates, which is called the azimuth angle and the altitude angle. So that is what we're going to look into it today. Okay. And okay. So here, you guys have started on your design, right? And a couple of people we've been, when we are doing our design for the pavilion, we've been asking for sun path diagrams. Do you guys recall this? Do you guys remember seeing any drawing like this? What you see here? Can I see the circle here with the degrees represented all
Yes,
across?
sir. Yes, sir.
Have you guys looked into any sun path diagram like this for your design? Technically, it will be something like
Yes,
this.
I mean, I've seen quite a lot of them in
Sorry?
YouTube while I was really trying. I've uh, I've seen some in Google and YouTube
Okay.
while I was figuring out what exactly that was,
Okay.
but it didn't quite get into my mind.
Okay, fine. So this is called a stereographic projection. A stereographic projection is nothing but uh, just yes, one minute. Sorry, guys. Sorry for. Okay, as Maitri said, so here this drawing is what we call as a stereographic projection. So first we'll see what is stereographic projection. Do you guys know what's a stereographic projection? If anyone here, just as an informative.
Yes.
Okay. A stereographic in geometry, a stereographic projection is a particular mapping that projects a sphere onto a plane. So what we see as the outer atmosphere, as in where the sky is, we map that up on a paper as like what is the movement and where do we locate it. So the best example is how does a stereographic projection work is I'll show you an example, and then probably from there you'd be able to understand it much more better. Okay, this is a stereographic projection. So what the point at the top, the dot here, that is a point of view from where we are looking down. And how the circle is going to be projected is described as this. Do you see this center line? That's a equator, whatever point, the outer diameter. These are projected onto the paper and they are mapped across. And all of these longitudes are again mapped across on the same appropriate manner. So this is a stereographic diagram. And with this reference, we look into what is the details given in the stereographic diagram and what is that we need to learn about. Okay, guys. So before getting, this is a stereographic diagram. What do you see here is outer diameter, outer circumference, which has got degrees represent starting from 0 to, okay, the outer circumference here represents a 0 to 360 degree. That is one characteristic of it. Another thing you find here are these concentric circles which go from the center. If the point here is the center, then it means 90 degree. If the concentric circle points extends every 10 degree till it reaches up 0. So these are two components. I just want to introduce these. And now I'll tell you what are these two components which are there. So these are the two elements, as like what I said about the GPS. We're going to look into the same part here. You guys are able to see the screen, right? So here, there are two things. One is called the solar altitude angle and the solar azimuth angle. Altitude angle is nothing but an angle which is inclined to a viewer wherever a person is standing. The vertical angle it falls down. Uh, Example is one. You guys have gone to a beach to view a sunrise. Any of you?
Yes, sir.
Okay. So can you all visualize this point wherein like you guys are facing the east and you're visualizing a sunrise? And 6 o'clock, to be on a generic term, 6 o'clock, I keep it as a point when the sun starts to come over the horizon and it starts to climb up. The time when it starts at the horizon. So what is the angle it comes in, as in once it starts to appear to the point where you're standing? What would be the angle here? The sun is at the horizon, it's just popping up, and you're viewing it straight across. What is the angle difference between the sun and you? Guys, you're able to understand what I'm trying to say? You guys are visualizing a sunrise
I
on
don't
a,
understand the question, sir.
okay, you're on the beach visualizing a sunrise. You're seeing a sunrise from the horizon, which is climbing up. This is 6 o'clock in the morning. Okay, the sun is just reaching the tip of the horizon to just pop up. So now tell me, what would be the angle from the sun to the point where you're standing? You guys are not able to understand the question again. Can I have a feedback on what is
So
the
zero.
problem? Sorry, Sanjay?
Zero, sir.
Yes.
Yes, sir.
How do you relate it? Because it's at the horizon. and the point you're standing is at the same level. So you don't have any
Yes, sir.
degrees at all. But after 1 hour, the sun rises up, right? The sun rises up and it goes into another point. And what is the angle at probably I'd say at 8 o'clock, after 2 hours, 8 o'clock? The sun is at some elevated point and you are standing at the same point, or you can be rotating into another point. So what is the angle it would have created? Probably some 30 degrees by then. You guys are. So this angle, what it otherwise, okay, much more simpler example. 12 o'clock in the afternoon, the sun's right above you, straight above your head. So what is the angle between you and the sun?
90. I mean,
Yes,
the origin and the sun.
yes. It's 90 degrees. That is what we are speaking about is the sun's altitude angle. Am I clear to you guys, all of you? This is very important. I don't mind taking time, explain it to you. I'm giving you real-time examples to have an better understanding rather than just reading out. Okay, fine. Otherwise, I'll read it out here, probably see whether it's understandable. The solar altitude angle. The sign here given is a gamma, the vertical angle of the point of observation between the horizon plane and the line connecting the sun with the observer. The vertical angle at the point of observation between the horizon plane and the line connecting the sun with the observer. Is this definition easy enough for you to understand, guys? Can you please respond? Otherwise, I'm really not sure whether you guys are able to understand this or not.
So I understood it.
That's 1%. I want other people to also, as in, like, you guys can ask me if at all you're not clear with what I'm saying, then I can rephrase it and I can tell you. There's one concern given from one student out of here. All of you guys here.
Sir, I'm not clear. Can you explain once more?
Okay, Shubh, imagine you're standing, you're going to be the afternoon sun is our example. So what is the point which is mentioned here is the vertical angle at the point of observation between the horizon. What is the horizon, Shubh? You know what's horizon?
Yes.
Horizon is the point where the sun rises and the sun sets, or where it starts to appear and where it tends to disappear. So what is the angle from the level of horizon to the point, as in if you're the viewer, what is the angle difference of the sun? So what is the exercise we are trying to do here is we are trying to map the position of sun on the sky to understand where exactly the sun travels. Okay, so the example here is, that's why I quoted an example in a much more simpler term. If at all you are viewing a sunrise, you're viewing a sunrise, have you viewed a sunrise? It starts to pop up from the horizon. Shub?
Yes, sir.
Yeah, it
Yes,
starts
sir.
to arise from the, it starts to climb up from the horizon. At that time, example, probably 6 o'clock in the morning, and there is a sunrise. You are standing, you're facing the sun, and the sun is just popping up. So, what is the angle between both of you? Angle difference between you and the sun. Your, which is mean, what I mean as you is means the point where you're standing. You both
Sir,
are in the,
zero.
yes, zero, exactly. So that is zero. Probably, and after some time, after 3 hours, probably 9 o'clock, the sun would have risen up somewhere.
Yes, sir.
So probably, what is the angle from the sun to wherever you're standing? Can I say somewhere around 40 to 45 degrees?
45. Yes,
Yes.
sir.
It's not exactly 45, but to understanding, it's fine. What we are saying is this is a solar altitude angle.
Probably 45.
Yeah, probably. Could be. But just for understanding it. I'll tell you how to go about the drawings and how to read from each location. Each location have a different parameters. I'll tell you on that. So next point is 12 o'clock. We'd say the sun is right above us. 12 o'clock in the noon. So what is the angle between the sun and you?
90 degrees
90, exactly.
probably.
So this is what is called the,
Perpendicular.
yes. So this is with the reference to the horizon. Wherever is the horizon, we take the angle. Okay. This is the
Okay, sir.
sun solar altitude angle. What you're going to map from 0 to 90. Its limit is only this. By the time when the sun is going to set again, it again goes down from 90 to whatever point and it goes to 0. When the sun is setting onto the west side on the horizon, then it again becomes a 0. So this way you'll be able to understand at what angles, at what different times the sun travels. Clear? This is solar altitude angle. Now, I'll just read the example for read the information for solar azimuth angle, and then I'll explain you what it is. The solar azimuth angle alpha, that is the angle at the point of observation. The angle at the point of observation measured on a horizontal plane between the northerly direction and the point on the horizon circle, where it is intersected by the arc of a vertical circle going through the zenith and the sun's position. And there is an example also given. Imagine you're going to be, can you visualize this drawing? You're able to see the circle here? Guys?
Sun.
Okay. Now we spoke about solar altitude angle, right? So the altitude angle is what I was mentioning to you is about all of this. This center point. What we are looking at 0 is the north. What we are looking at the east is 90. What we're looking at the south is 180. And what is at the west is 270 degrees. Clear? So this is the orientation. And here, imagine a sunrise. Where does the sun rise from? Which direction? I want you guys to participate, please.
90 degrees from 90 degrees. East.
Muslim, don't, yeah, go on to the first character. At which direction it starts from? 90. Okay. That is, now you said 90, right? The difference, I'm at the center, the dot, this is me. And when I say the sun rises from the east, which is 90 degree. So there is a reference taken from 0 to 90 here. This angle, what mentioned as east and 90 degree, is your solar azimuth angle. Okay. So, okay. Now coming to this point, the second point. I gave you an example of the sunrise, right? At sunrise, what is the altitude angle? What is the altitude angle at the sunrise? Where does the sun rise from? Guys, are you there? You guys, can you respond? We just spoke about a couple of minutes back about altitude angle. So what is the altitude angle? What is the angle difference between the sun and you? What is it at sunrise?
90 to 270.
Musham, understand
So
this point. Altitude angle. There are two things. You said the sun is rising from the east. I'm standing here at the center, the dot, and the center. If you see the mouse pointer here, so
yes, sir.
the 0 to 90 degrees. That's the reference. What you said. That is called the solar azimuth angle. The horizontal solar
sir.
azimuth angle is nothing but what is the horizontal reference from zero, as in from the north to the any other part where it's moving, is called the solar azimuth angle. Now, the altitude angle is I'm standing here, the sun is at the position, the azimuth position of 90 degrees, that is horizontally. What is the altitude it's going to climb up? Uh, you guys are still not clear. Okay. Just a minute. I'll just. I'm making a sketch which I'll be sharing now. Guys, this is quite an important content, so I want you to spend time and understand this. Okay. Altitude angle. Okay. Guys, I'll send it to you in WhatsApp. Can you just check it up? Can you check the group, guys?
Yes, sir.
You guys received the drawing?
Yes, sir.
Yes, sir.
One of you, can you screen share? I'll stop sharing. Can you screen share the drawing? Because I'm not able to do it now because I just got it from the picture. Akshay, Maitri, one of you, can you screen share the drawing? Or no?
Yes, sir.
Others, have you looked into the drawing? Why am I not
Yes,
getting
sir.
a... Yeah,
Yes,
thank
sir.
you, Rishita. Thank you.
Sir, it's unable to share it, sir.
Can you check now? Aksha, can you check? If anyone else is able to share, also please share. Aksha, yes. Okay. Akshay, can you just rotate your phone into a landscape? Okay, fine. Guys, here I was mentioning about both the angles, right? First, look into the altitude angle, which is at the bottom of the page. In the altitude angle is almost like a section wherein you're standing on the ground. There is a person on the center, and the angle goes from the east to west. The angle at the sunrise, what you call, if I'm the person looking at the sunrise, it's zero. The altitude angle is zero. Probably by around 9 o'clock, the sun goes into a elevated position. And what is the angle from the sun's position to the user location is 45 degrees. Similarly, by noon, the sun goes into 90 degrees. Okay, and as in it's right above us and above our head, it's 90 degrees. And what happens in the afternoon again? The sun comes down towards the west. So whatever angle it's going to make, probably it'll again step down into 70, 45, 30, and 0. This is what we call as the altitude angle. Remember, this is the angle which comes from the elevation. You guys are clear now? Guys, you're able to understand this logic?
Yes, sir.
Yes. Okay. Now let's go into azimuth angle, one on the top. So azimuth angle is a reference on the horizontal plane. On a horizontal plane, imagine you are at the center. The north direction is 0. Always the reference goes from the north direction. So this point is 0. I gave you an example of the sunrise, right? Where does the sun rise from? The east. So what is the degree here? 90? You guys are able to understand this? The sun rises.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, the
Yes,
sun
sir.
rises. So you always take a reference from the, you always take an example from the north. The sun rises. Probably around noon. The sun goes towards the center, as in any central line. What do you think would be the angle? How does the sun path travel? The sun rises in the east, takes a dip to the south, and goes to settles in the west, right? At in the noon,
Sir, it
it
will be
comes.
zero again.
Sorry, yes, Shub.
Sir, will it be zero again?
No, no, no. You're always taking a reference. I'll tell you what. When the sun is moving, you always take the reference from the north. You always take the reference from the north. From 0 degrees, you come to the south, as in like the sun rises in the east, it travels down to the south, which means the angle of reference at the noon, 12 o'clock, would be from 0 to south. What is the direction at south? 180 degrees. You get the point. The azimuth angle is horizontally or locating where the sun is located. Probably much more easier example is, imagine the sun is setting at west. What would be the position then? Sun sets at the west, right? what would be the position? What is the angle, the reference? Guys, what is the angle reference from north when the sun is setting at west?
270.
Yes. So you take all your positions with reference to north. That is azimuth angle. This is done horizontally, as in like imagine you're just watching the sun and you're moving across. When you're watching at the sunrise, you're facing the east, 90 degrees. When you're watching the sun at 12 in the noon, probably you'll turn down to south and look up. It's 180 degrees. And when you're watching the sun setting at the west and you're following the sun's movement, in that case, you will turn to west, which means that the sun's position is 270 degrees. This is azimuth angle. Clear? So altitude angle is just that angle vertically. You're making a reference to vertical connection, whereas azimuth angle, you're making a connection horizontally.
Yes, sir.
Clear?
Yes, sir.
I don't think everyone is clear. Is like anyone still holding their doubts and you still don't think it's working out? Otherwise, okay, what I'll do is, so I have an understanding about this. Azimuth angle, you're working out horizontally with the reference from the north. Altitude angle, you're working out your angles from where the sun rises to where the sun sets. So that is vertically. This one, azimuth is horizontal, altitude is vertical. Just have an understanding. I'll show you example. Akshay, can you stop screen sharing? I'll screen share. Thank you, Akshay. So I'll show you an example. So this is a stereographic diagram. Now I'll get you into a stereographic diagram of Chennai itself and show you how to work out the sun path. Okay, is able to see the screen? So
Yes, sir.
this is the website. You can take a screenshot of this website, andrewmarsh.com software.sunpath. You can just go to Google and type as stereographic projections sunpath. You'll get this website. In this, there is a launch. In this, because of Mac, it's not compatible with Java. Whereas with the Windows, you'll directly open up into a screen like this. You guys are able to see the screen here? Guys?
Yes, sir.
Okay. So I've already now here with this position, you can actually choose your location globally anywhere. What is the location for Chennai? What is the latitude and longitude? Chennai's latitude and longitude 13 and 80. You guys are able to see the screen here? What are the coordinates given here? Latitude of 13° north and longitude of 80° east. So this I've already mapped it here. This is the latitude and longitude. So normally here, in this chart, the default option would be a spherical. But what we technically use is a stereographic representation. This is on the chart. I've mapped the position to Chennai. So this is a sun path of Chennai. Now we look into what happens. What is today's date? 5th of October. You guys are aware of the dates? Okay. I'm not precisely able to stop it also. Okay. Fine, I'll put it at 4th. Do you guys see what are the details given here? I'll go to 6 o'clock. And do you see what is the sun azimuth angle given here? 97.17 degrees, which is with representation from the north to what it is here. What is the reference from the north? The altitude angle is, as I said, what happened? It just rising up from the horizon. So it is 10.91. Now, can I go to 9 o'clock? So as I move around, time of the day, do you see the sun, the red dot moving out also here from this position? 9 o'clock. So now what is the sun's azimuth angle? From the north, it has come on to 115 degrees. And the sun's azimuth altitude angle, it is rising still above. So this gone to 51.96 degrees. What happens in the afternoon? 12. The sun's azimuth angle is come to 144 degrees.